Hello, space enthusiasts and curious minds across the globe. Today, we've got something utterly mind-boggling to share with you. Recent observations from the James Webb Space Telescope have left scientists scratching their heads in bewilderment. Reports indicate that trillions of stars, previously documented by astronomers, have suddenly vanished from the observable universe. This startling discovery has the potential to shatter our current understanding of physics. Stick around as we dive deep into this cosmic mystery and explore what it means for the future of astronomy. Solar systems, the foundational elements of our cosmic neighborhood, have undergone an unprecedented transformation. An astonishing total of 771 trillion solar systems have vanished without a trace, leaving the scientific community in utter disbelief. What unfolds next is truly astonishing. From the far reaches of the universe, unknown entities have started to emerge, compelling us to seek the truth behind the sudden disappearance of 771 trillion solar systems across our expansive cosmos. Is there a link between these missing solar systems and the mysterious figures emerging from the depths of space? Join us as we dive into the unraveling cosmic mysteries of disappearing stars. Over 771 trillion solar systems have disappeared, and a disturbing new phenomenon has appeared from the cosmic abyss. We aim to explore possible reasons behind the disappearance of these solar systems and examine the impact of this baffling cosmic event. Humanity has devoted thousands of years to mastering fields such as science and mathematics, which have enabled us to understand our position in the universe and the fundamental nature of Earth. Despite these efforts, many aspects remain enigmatic, but one thing is clear. The concept here is that matter doesn't simply vanish, it transforms. In the same way, when a star explodes and seems to disappear, its material is scattered across the cosmos, continuing to exist in a different form. This introduces a fascinating mystery in outer space, the disappearance of stars from our night sky. At first, this may not seem particularly unusual, considering the vast expanse of the universe. Stars can suddenly vanish for various reasons, such as reaching the end of their lifespan or being engulfed by a massive entity like a black hole. However, what makes this scenario baffling is the scale of the disappearance. It's not just a few stars that are missing. There are countless stars, more than 700 trillion, that have mysteriously vanished, leaving astronomers puzzled about how they could have disappeared so suddenly. While the occasional disappearance of stars can be accounted for in a universe as immense as ours, the vanishing of hundreds of trillions, especially those not nearing the end of their life cycles or facing external threats, poses a completely different challenge. Fortunately, a dedicated team of scientists is working relentlessly to solve the mysteries of the cosmos. Beatrice V. Roll from the Nordic Institute for Theoretical Physics in Sweden highlights their efforts. She explains that their project, known as VASCO, is a monumental endeavor. Discovering a star that has been a consistent fixture in the night sky throughout human history and recorded observations only to suddenly disappear without a trace is a phenomenon that even the most sophisticated telescopes have been unable to explain. Villa Roel highlights that the VASCO project's mission is far from a mere flight of fancy. Since its inception in 2017, the project has captured significant interest, with each team member bringing their own unique motivations to the endeavor. The team concedes that certain mysteries of the universe remain elusive, given the immense distances involved, which complicates the task of cataloging every celestial body with perfect accuracy. Nonetheless, they are optimistic about their chances of identifying a new type of event, a star that vanishes from the night sky without prior documentation of such a phenomenon. Villa Roel points out that while variable stars, which exhibit changes in brightness, are known, their transformations typically span years at most. The objective here is to find a star that goes from a state of unwavering constancy to complete invisibility, a breakthrough that could open new avenues in physics. You might be curious if it's actually possible for a star to vanish without any warning. The answer is yes. For instance, astronomers had been tracking a star for over 2 decades until it disappeared in 2019. This particular star captured their interest due to its brilliant crystal blue glow. Then, without any forewarning, it was gone from their telescopes. Andrew Allen, a doctoral candidate in astrophysics at Trinity College Dublin, took a thorough look at the data multiple times. The leading hypothesis was that the star had exploded in a supernova and became a black hole, yet there were no detectable traces of a supernova explosion or the expected remnants. Moreover, the absence of any visible black hole, considering the interval between observations, made it highly unlikely that such a significant event could have been missed. If the star did indeed become a black hole without undergoing supernova, this would constitute a case of disappearance without the usual dramatic evidence. This puzzling event has astronomers searching for explanations, delving into clues that could shed light on this enigmatic phenomenon. Occurrences tracing back to 2009 involve a star that had caught the attention of numerous telescopes, seeming on the verge of a significant event. This star experienced a sudden transformation into a black hole before scientists could fully understand the process. While definitive proof is still out of reach, this incident has left astronomers puzzled. Equally important is the joint effort among various research teams, including those previously mentioned, to compile detailed star catalogs and their characteristics. These catalogs allow astronomers to access star data online and make thorough comparisons. The results have been both encouraging and remarkable, with researchers identifying numerous short-lived transients that appear briefly in one image before vanishing, making up the bulk of their discoveries to date. However, there are still distances across galaxies, introducing a thought-provoking perspective on the observation of celestial bodies. The essential question of how we are capable of perceiving anything at all finds its answer in the realization that the myriad light rays emitted by stars take an incredibly long time to reach us. Even when they finally do, they merge with the rays from our own sun, making them visible in our night sky. In fact, the light we observe is often many years old. For example, although the sun is relatively close to us, its rays still take about 8 minutes to reach Earth. When considering stars that are light years away, the age of the light we see becomes profoundly apparent. The seemingly sudden disappearance of stars could be attributed to the vast age of the light we're observing. Though it seems instantaneous to us, the star may have actually ceased to exist long before, and we are just now becoming aware of its absence. This insight also relates to which further deepens the intrigue and complexity surrounding our quest to decipher the mysteries of the universe. Among the more fascinating theories considered by astronomers is the idea that vanishing stars could be linked to extraterrestrial beings. One might wonder, how could extraterrestrial beings make stars disappear? The explanation doesn't involve the literal disappearance of stars, but entertains the captivating possibility that these vast celestial bodies could be harnessed for alien purposes. The concept of a Dyson sphere, though still within the realm of science fiction, proposes a scenario where advanced alien civilizations, or exceptionally rare occurrences on Earth, might involve the construction of a megastructure that encircles a star. This megastructure would act as a means to capture and utilize the star's energy on a grand scale, effectively turning the star into a gigantic source of energy or even a powerful tool. This idea is somewhat mirrored in popular culture, such as in Star Wars: The Force Awakens, where the Starkiller base uses a star's energy to destroy several planets of the Republic. However, the plausibility of such an explanation encounters significant challenges. First and foremost, the existence of extraterrestrial life has yet to be confirmed. Additionally, the creation of a fully operational Dyson sphere, even around a relatively small star, faces immense technical and material hurdles. Constructing a Dyson sphere around even a modest star would require a significant amount of time and a level of technological advancement beyond our current reach. When considering the application of this concept to more than 700 trillion stars, the task escalates to a colossal galactic project, casting doubt on its feasibility. Yet, the idea continues to attract supporters. So, where does this leave us? we find ourselves without clear-cut answers. What is certain, however, is that something extraordinary is happening in the cosmos, leading to the disappearance of stars from both our observations and our skies. This phenomenon cannot be dismissed as mere chance, given the notable absence of a vast number of stars. The persistent question is what could cause such a large number of stars to vanish in a relatively short period. This is the driving force behind the dedication of individuals and organizations from various fields to solve this enigma. Unraveling these mysteries could offer us a deeper insight into the universe and prepare us to better understand and quickly identify the causes of similar phenomena should they occur in the future. As the mystery of star disappearances continues to puzzle us, a new discovery has been made in the vastness of space. Scientists have recently identified enormous voids that exceed our previous conceptions. These voids span incredible distances, from the scale of our solar system all the way to the Milky Way, marking regions in the universe where celestial bodies are remarkably scarce. Among these, one particular void stands out, the Boötes void, often dubbed the Great Nothing. Looking up at the night sky, it appears as a vast, evenly distributed canvas of stars, but the Boötes void presents a stark contrast. This region harbors very few celestial objects, illustrating the universe's unique structure with long filaments of dark matter interconnecting galaxies and galaxy clusters interspersed with vast, empty spaces. The Boötes void, with a diameter of about 330 million light-years, is located near the Boötes constellation and lies roughly 700 million light-years from Earth. Initially thought to contain only one galaxy, subsequent observations have only identified a few dozen more within it. The average distance between these galaxies is about 10 million light-years, which is 4 times the distance between Earth and the Andromeda Galaxy, highlighting the vast emptiness of this region. The stark difference becomes evident when we compare the Boötes void to our own cosmic neighborhood, the Virgo supercluster. The Virgo supercluster, significantly smaller, spans about 110 million light-years in diameter and hosts over 2,000 galaxies, including our own Milky Way. To illustrate the sheer emptiness of the Boötes void, astronomer Greg Aldering once remarked that if our Milky Way were located at the center of this void, we wouldn't have discovered other galaxies until the 1960s. By contrast, the Milky Way is surrounded by approximately 24 neighboring galaxies within a region only 3 million light-years across. Given its size, the Boötes void could theoretically accommodate around 10,000 galaxies, assuming typical intergalactic distances observed elsewhere in the universe, which are generally a few million light-years apart. Yet, astonishingly, only 60 galaxies have been identified within this vast emptiness, making them some of the most isolated galaxies known. The Hubble telescope has even captured an image of one such galaxy, MCG plus 1215, a spiral galaxy residing in the Boötes void. The European Space Agency has dubbed it the loneliest of galaxies, and how it came to be so isolated remains an enigma. In the image, 3 stars from our Milky Way can be seen in the foreground, accentuating the isolation of the galaxy in the void. What appears as points of light, resembling a swarm of tiny organisms in a droplet of water, are actually distant background galaxies. The formation of voids, according to computer simulations, often results from the gravitational pull of galaxies, which draws them closer together and leaves empty spaces in their wake. However, this explanation falls short when it comes to the Boötes void, as there simply hasn't been enough time since the universe's inception for gravitational forces alone to carve out such an immense void. This brings us to the Big Bang theory. When most envision the expansion of the universe following the Big Bang, they might imagine galaxies evenly dispersed, moving away from one another. Yet, a more complex structure emerges upon examining the universe at its largest scales, akin to compressing billions of light-years into a cube the size of a computer screen. If we were to turn back the clock to the universe's nascent moments, just after the Big Bang, the universe was a densely packed sphere of intensely hot plasma. Despite its mostly uniform density, there were minor variations or quantum fluctuations that played a significant role. As the universe expanded, those minor variations in matter density became increasingly significant, leading to areas of higher and lower matter densities across cosmic scales. Fast forward 8 billion years from the Big Bang, and we witness how these small anomalies from the universe's infancy have evolved into the colossal structures observable today. These structures resemble immense walls, each consisting of thousands of galaxies rather than individual ones, connected at nodes where filaments of galaxies meet. These structures are massive, spanning thousands of galaxies across and hundreds of millions of light years in size. The voids that lie between these galaxy clusters are even more expansive. While not entirely devoid of matter, these voids possess a lower matter density compared to regions teeming with galaxies, typically about 1/10 of the universe's average density. Thus, these voids still house dark matter, gas, dust, stars, and galaxies, albeit in lesser quantities. For example, within a single massive void, there can be as many as 17 different galaxy clusters. As the universe continues to expand, these voids, including the Botez void, will also grow. The walls and filaments that link clusters of galaxies will stretch further apart, emphasizing the intricate and dynamic structure of the cosmos. As these voids expand and merge, the fabric of the cosmos will stretch and eventually break apart, leaving behind galaxy clusters that are only connected by their gravitational pull. This process highlights the truly astonishing scale of the observable universe. Within this immense expanse, we find ourselves in the local group, which is part of the Virgo supercluster situated near the edge of a cosmic void. Yet, there is still much more to uncover in this vast universe. To date, astronomers have discovered the largest known structure within the cosmos, a massive void referred to as the supervoid. This supervoid extends over an impressive 8 billion light-years in diameter, notable for its profound emptiness. The discovery of the supervoid has provided answers to long-standing questions that have captivated scientists for years, while simultaneously introducing new inquiries that hint at the possibility of unique physical phenomena. The density of cosmic matter, including galaxies and dust within the supervoid, is approximately 20% lower than that found in our region of the universe or any other area with a standard density. Although it is not completely devoid of matter, the supervoid presents an image of a vast, cold desert in comparison to the more densely populated regions of space, underscoring the diverse and enigmatic nature of the universe. The supervoid's connection to the discovery of the cold spot, a region in space identified over a decade ago for its unusually large size and lower temperature, contrasts with expectations based on its cosmic microwave background. See MB radiation. This radiation is the thermal afterglow from the Big Bang. Scientists have long sought a void in this area because photons, while traversing an expanding universe, lose energy and cool down when passing through a void. The hypothesis has been that confirming the extremely low density in this region could elucidate the cold spot's existence. This cooling effect occurs as photons transition from denser regions of the universe into a void. Here, their kinetic energy is transformed into gravitational potential energy, leading to a temperature decrease. Consequently, light exits the void with a longer wavelength and at a colder temperature. To investigate the number of galaxies in a space region approximately 3 billion light-years from Earth, Istvan Sapir from the university embarked on this inquiry. The challenge was accepted by Istvan Sapir and his team from the University of Hawaii, along with Andres Kovacs from ETVS Loren University in Budapest. Utilizing the PAIN-ST ARRS-1 telescope in Hawaii and NASA's Wide Field Infrared Survey Explorer satellite, their research uncovered that the cold spot indeed lies within a significantly underpopulated region of galaxies. Although this structure may not appear as a distinct entity, it is quite extraordinary, given that the cosmos typically exhibits a relatively uniform distribution of matter on such scales. Unfortunately, The supervoid accounts for only about 10% of the temperature differential observed in the cold spot compared to the average temperatures of surrounding galaxies. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.